Okay, so why audit a database? Auditing your database, besides ensuring operational efficiency, like I had mentioned earlier, kind of helps to protect against data breaches. It helps you with things like compliance to different regulations depending on your jurisdiction, right? It protects you against data breaches. It ensures efficiency. Don't forget that the audit function is about adding value, improving operations, right? So there are certain recommendations that you make that help build system resilience. So for instance, you see a critical system where you don't have a backup, for instance, that should be a cause of concern, because what kind of redundancy plan do you have in place should that system go down? So that's why, so the whole idea is that at the end of our conversation today, we should be able to take one or two things around how we can provide that reasonable assurance on databases, right? So I'll call on Ganiyu to take us through some of the domains that we should actually be looking at. Maybe not all, but sample of domains that we should at least look at when we are auditing databases. Ganiyu.
Thank you very much, Tony, for the introduction. Please, can you all hear me?
Yes, we can hear you loud and clear.
I'm so honored to be presenting this morning, and I really appreciate our timeliness. So can you go to the next page, please? So while doing that, like Tony said in the introduction, we need to conceptualize our database and have a detailed idea of what our database is. I believe you all allude to the fact that the most crown jewel or the most important information for an organization is the data, which is our crown jewel, and that is why we are in business. And like Tony said earlier also, these are stored on databases, which makes these databases our crown jewel. And for every malicious actor or threat actor, I could remember this actor before, they will tell you, cut the head and the body is useless. Once you take the most prized assets, then the organization is as good as useless. So for us to have, I'll give two analogies for us to have an idea of what this means. So I have a Queen Elizabeth who stays in Buckingham Palace, and we all know how mighty and well constructed the Buckingham Palace is. And we eventually give the key to the gate of Buckingham Palace to a drunk man. It's as good as having no security. So this is pointing to the fact that while we have our prize jewel somewhere and we have so much security around the prize jewel, access to that prize jewel is fundamentally the most important aspect of security. And I'll give us another analogy, which I believe we'll all be able to relate with. If you remember when the Ukraine and Russia war started, there was this meeting between President Macron of France and President Putin of Russia. Despite them being in secluded places, I believe we can remember the long table that was in between them, where Macron was at one hand and Putin was at the other hand. This still speaks to access control. Who have access to me? Despite being two presidents, they can't afford to sit table to table. It's around security conscious. So you'll be hearing much dimension of how database is being accessed, how to secure the access, and it will come in different size and version. So we should just have that. That analogy gives us an impression of when we lament more on access, we have a better idea of why access is very key. So we look at auditable entities, we look at access control, physical, remote, logical, and everything. We also look at the operating systems for database and the relationship between the two. We look at file and directory permission, network access permission, database and database object itself, look at audit activities. Then we also look at the backup. Please can you go to the next page? So while talking of logical access control, I believe we all know what logical access is. And there are two main components of logical access. That is the authentication and authorization. Authentication is the act of you proving your identity. How do I mean? I've been created on a database. For the database to give me access to itself, I must prove that the user you have on yourself is actually me, which means I authenticate myself with my username and password. And probably in an instance where we have multi-factor authentication, I also provide OTP or paraphrase, depending on what is implemented. Then the authorization bit now comes after authorization. So the authorization bit now comes after authentication. Once I've successfully proved my identity, the authorization now determines the types of rights or privilege I have on the database. And this speaks directly to what Tony said earlier in terms of privilege misuse. So as an auditor, one of the core things we look at when, please, can go to the next page. One of the core things we look at is the custodian and ownership of all profiles on the DB. How do I mean custodian ownership? Every user that is created on database must have an owner. And that is where, from governance perspective, we have what we call the user access matrix, right? Which shows what a user should have, how a user should be created, the type of role it should have. So at the end of the day, every user created there must be accounted for. You know who owns it, and there's a justification for what that user is being used for. So in the advent that we cannot establish a owner to a particular user, then it becomes an observation that needs to be investigated further. What could go wrong when we talk about logical access, which is a combination of authorization and authentication? The first thing we look at is around the weak password management. There are several controls around password management. We talked about password complexity, account lockout threshold, password history. So these are three core features of password management. The complexity is about the number of characters that can make up a password and the length. And what this ensures is that it becomes more difficult for you to break or to guess that password. The next thing is around the account lockout threshold. This shows how the system should treat failures of authentication. So if I supply 3 wrong passwords, it sees it as a potential attack and it locks that account. So what this gives us is it helps us to prevent a brute force attack. Then we have the password history. This ensures that we are not repeating a password. Depending on the policy, best practice says minimum of 12. Some say 25, depending on what organization policy says. It shows how well we are changing our passwords in terms of not using the same old password. And another core risk when it comes to access is around default users and default passwords. When databases are being onboarded from initial, there are some default users that comes with these databases. Things like guest, things like SA, things like anonymous. Best practice is, and unfortunately, most of them either comes with no password or the passwords are known, they are in the public domain. So the best thing is all these generic users should be disabled or deleted, depending on how we tend to manage them. But the main goal is that they should not be accessible or they should not be usable. And another area where, in terms of our risk, is around how we manage profiles of exited staff. When you see a user who has left the bank and the profile was not taken off and someone was able to use the profile to access the DB. Then the other thing is around users who change role. So I have a Ghanaian who was once a network administrator. I have all appropriate roles and rights for network administrator. Based on job rotation, I was moved to a system admin role. My network access was not taken off me. I accumulated all privileges for system admin. And after a while, I was moved to a database role, and I also accumulated all roles for DBA. Eventually, I could single-handedly compromise the entire system because I have privileged access on the network, on the system, and on the DB. So again, this speaks to what Tony said earlier around privileged accesses and how we manage these accesses. So this also speaks to the access control matrix and how we intend to manage user access once they are leaving. So in the process of auditing, we should be able to review
Don't
and
say
align all the
man.
roles and
People that I will
privileges,
pay this one. You understand?
all the roles and privileges assigned to each user to see
Am I
if there is a
waiting for you?
deviation or if there is an excessive user profile for each of these users. Please can we go to the next page? So on the next page, we talk about network access and permission. Like we all know, database does not stand. Can we go to the next page, please? So like we all know, database do not stand in isolation. For we to have an enterprise, data flows along the entire organization, from end user to application, from application to databases, from application on the internet to the DMZ to the database, which means we can't speak of protecting our database without talking of network access, because network access governs how data is being moved up and down the enterprise. So when we are now looking at network access permission as it relates to database, the first point of duty we need to take care of are the default ports and listeners configured on our database. How do I mean? I wouldn't know if we've accessed a database before. For every database, you have a port through which you connect to it. Most database comes in with default port. For example, MS SQL, you have the port 1433. Oracle, you have the 1521. MongoDB, you have the 12071. So all these are generic ports that comes in by default with your database. Best security practice says we should not use these generic ports or listeners. We should change it. And why should we change it? For every cyber incident or cybersecurity attack, we have what we call the seven Q chains of cybersecurity. The first attempt by a malicious user is always what we call the recognizers attack, trying to get information around our organization. So I know the default port for MS SQL is port 1433. I start listening to what is being traversed along that port. I believe any traffic I'm seeing is going to a database. From there, I can now start mapping how the organization looks like. From mapping a database, you get to get the IP address, get the name, try and sniff who is accessing, try and see how you can get a profile, and so on. So the first thing is trying to even nip it by the bud. We don't want that reconnaissance attack to even happen. And one of the controls is to ensure we are not using default port and default listener. And we also ensure we block things like pinging. You should not be able to ping the database except you're authorized to do that. You should not be able to do a trace route except you're able to do that. So all those things are the preamble or the initial controls we have when it comes to network access. The second one is around separation of server from database. I will not dwell much on that. Tony has already spoken much in terms of its application. So one core area I would also like to speak about that is applications on the DMZ. DMZ is called the demilitarized zone. How do they access our database? We expect maximum control should be between those applications and our internal infrastructure. Then again, as an auditor, we must be able to evaluate those controls in between those segments. Then another thing we'll quickly speak about is the segregation of function, which I've spoken earlier in terms of a user accumulating as privileged access across several functions. We must have clear segregation of function. And the objective is that one individual should not be able to start and end a compromise without any other system interference, which means a user should not be able to compromise the entire system. Each profile, the profile for each user should be aligned with their job. Then the last one we'll be speaking to here is the firewall and perimeter device. I won't speak more to it. Tony already spoke about it at the beginning from the presentation he showed, where we have different line of defense. And I recall he made one key statement which should be aware of, that having this defense in depth does not give us an absolute assurance that we will not be hacked. All it does is it reduces the risk or probability that will be hacked. And again, one of the things that big organizations fall prey to is, we call it a shining glass of armor. How do I mean shining glass of armor? You have a big organization. Do you have a dam? I have a dam. Do you have an IPS? I have an IPS. Do you have a threat intelligence monitoring, I have it. You have a firewall, I have it. You have all the solutions in place, but they are not properly configured. You have everything blinking and shining, but a single attack will bypass all the controls on all these security tools. So as an organizer, as an IT auditor or an assurance officer, we need to be sure, we need to understand our defense in-depth architecture and ensure the function of each of those devices that are meant to provide the layered security for us are well configured, so that we are not just having them for having sake. They are well configured to work the way they should work. And in this case, we are looking at access to database. They are well configured to filter as much access as possible based on what they are configured to do. And again, a quick way we can gain an understanding around this is to have an approval or a business justification of why those applications were purchased in the first instance. Look at how best standard they should be configured and check if they are configured in line with all those arguments. Then we can give an assurance of the protection of our database. So the next one is around the operating system. So we are saying database review and we are mentioning operating system. What is the correlation? I remember someone once told me that to auth a mother, all you just need to do is auth the child. And to auth a child, all you just need to do is auth the mother, right? So the operating database do not stand alone. In every database, you have a bare metal, which is the physical server, which is running on an operating system. Then on top of that operating system, a DBMS solution is installed, which means our database is not a standalone. It relies on our operating system. So if our setup is as strong as the weakest link, no matter how secured our database is, if our operating system is vulnerable, the vulnerability on the operating systems can be translated to the database. And when we won't dwell much on the operating system, right? But we'll just look at what area we should look at on the operating system. We should look at user management and authentication. Users who have access to that bare metal, the physical server where our database is installed, who are they? What sort of rights do they have? How are they authenticated? Can they do a remote logon? What administrative tasks can they perform? And what is the password policy? Mind you, it depends on how we structure our database or the environment our database runs. For example, if I'm deploying my MS SQL database, MS SQL database has two forms of authentication. One is the MS SQL authentication, which relies on the policy on the physical host, while the other one is the window authentication, which relies on the domain. So in an instance where you are using an MS SQL authentication on your SQL server, which relies on the password policy on your physical host, and that physical host has a blanket policy, no password complexity, no password expiration, no account lockout policy, no audit trail on the user access, and every other thing, and you even grant a remote access on that machine. Definitely, that vulnerability on the operating system, the database inherits it hook, line, and sinker. So that is why we need to give a concern and observation around what happens on the physical host that the DB is installed. Now we are looking at the security concerns on the operating system. Aside from what I've said so far, one of the major threats is regarding the file permission and file sharing. How do I mean file permission and file sharing? By default, we have a public folder on Windows whereby all I just need is know the IP address of that server, and I put in my whack IP address. It goes to that public shared folder. And at times, based on processes and the way we work, several parts are being shared. So on my server, unconsciously, a system administrator shared the D drive, and the shared was to everyone, and everyone have read-write privilege, right? Which means anybody can actually do a whack to that IP and have access to the C folder and the C drive. And we all know C drive is where the operating system lies, and that is where virtually the drivers, the backup engine, the MS SQL storage, everything, that is where it is. So once you have access, there are several things that could go wrong. You can do a database dump, which means you can pick the entire database engine and mount it on another server. So these are one or two issues that could go wrong as regards file sharing and file permission on the host server, which could translate to a vulnerability on the DB. The next thing is around the privileges on the shared profiles, right? So we have, for every privilege, we have, be it on Windows, be it on Linux, be it on Unix, there are three basic privileges, which is the read, write, and execute. So even if we are sharing or there is a need to share, appropriate privileges should be assigned to the users who will be accessing the shared folder, depending or in line with the nature of their job, right? So this, we should be very careful and watchful around all these shared access. So can we go to the next page? So the next page speaks to auditing activities and monitoring. I'll try and minimize my discussion on that. Tony already speak to monitoring and auditing and how most organizations leverage on a third-party solution to monitor databases and archive log based on the overhead of you turning on your audit logs. But again, like he said, it depends on the structure of the organization. If I'm an organization and I can't afford a damn solution, then definitely one way or the other, I need to turn on my audit log and probably pipe the audit log to a standalone syslog server so that it doesn't create an overhead on my server. But irrespective of how we are structured, what we are saying here is there must be audit trail in place for our database. And what does audit trail do? And why do we need to have audit trail? First and foremost, there is what we call non-repudiation. We should be able to know who does what, who is doing what, and the person who did it should not be able to repudiate or cannot deny the activity that was done by him or her. When this is done and users are being sensitized, it forms a deterrent control. You know, as auditors, we have several controls. At the end of the day, we should be placing layers of control. One of the control is a deterrent control, and that is what audit trail gives us. When a user is aware that his or her activities are being monitored, such user becomes conscious of what he does on the system, how he uses the rights that is being assigned to him. A case study of the DBA Tony mentioned. If the DBA knows that all his activities is being monitored and trailed, he knows he will eventually be caught, and he or she will be very careful as how he goes about his activity. So in terms of deterrent control, investigation, we all know, is part and parcel of an organization. There is no way nothing of investigation will not come up depending on what happens because of our normal operation. Then again, it gives us idea. Remember at the initial, we talked about authentication, authorization. One of the key ways we can see how how privileges are being used is through the audit trail. So if a Ghanaian who is an auditor, which we all know by best practice, by standard, and even by a nature of function, Ghanaian should and how the user is using the privilege that was assigned to him. So it's an indicator where compromise or abuse of privileges can easily be detected. Another reason why we should have this is it's a regulatory and compliance requirement. You can't pass your ISO, you can't pass your IPA, you can't pass your Basel without you having audit trail enabled. So it's not just a nice to have, it is regulatory backed. And we all know the consequence of violating the regulatory requirements. It's one of the easiest things that could wipe an organization off the growing concern. Then monitoring, we've already spoken about that. And another key thing we should be very careful of as an auditor is the completeness of the audit trail. Virtually all DB, by default, audit trails are not enabled. So it's a function of the administrator to enable the audit trail, and it's a function of the assurance officers, be it from security, be it from audit, be it from compliance, be it from control, to ensure that all the required logs are enabled, right? Which means it's a function, the completeness of audit log is very important. If the audit log are not appropriately enabled, when there are issues, it just becomes a noise because the most important things will not be captured. So we need to be aware of what needs to be what needs to be enabled, what needs to be piped, depending on the solution we are having, and we ensure they are well enabled. And apart from that, enabling is one, monitoring is the other. You having an archive of logs and things are going on, and there is no evidence that is being logged. As an auditor, you've not completed your job. To give that assurance, you must ensure the appropriate stakeholder that is monitoring is actually reviewing. How can we go about this? We know high risk activities, things like Tony said, attempting to drop a database. As a security person monitoring, such an incident should be investigated. And updates on a core GL or on a core table that naturally only a system process should update. Such process should be investigated. You have an application user and you know the application IP and the process is using the user. Unfortunately, you are seeing the user connecting from a normal user workstation. It's a point of compromise that someone is maliciously using the application user to log on. So those are things that you need to know what your key point of compromise are, see them in the log, and also follow through so that the assurance officer in charge of that space are actually monitoring efficiently. Because if you have the log and it's not being monitored, it's as good as having no log. So again, it's part of what we do as assurance officer to ensure audit logs are enabled and they are being reviewed as appropriate. Please, let's go to the next one, which speaks to vulnerability and patch management. I believe we don't need to talk much on this. We all know what vulnerabilities are, and we all know what patches are. Vulnerabilities are just anomalies, bugs, and what have you. Defects on a database. Anything defect is a vulnerability, either from application point of view, either from configuration point of view, either from installation point of view. They are all vulnerabilities. And we are saying once vulnerabilities are detected, patching comes in. Patching is the way or the approach we follow in remediating vulnerabilities. So vulnerability might be a software vulnerability, hardware vulnerability, process vulnerability. Irrespective of the nature of vulnerability, we should have a patch management framework or a patching process on how we address vulnerability, so that someone just don't wake up and do things the way it is. There must be a deliberate approach to how we address security and vulnerabilities around our database. This must be documented. There must be a process, and it must be followed effectively, right? So for vulnerability and patch management and process to actually work, there must be a program, right? And the program speaks to how do we detect our vulnerability? Is it that we run a scan? Is it that we consult a third party consultants to do the scanning for us? Are we sure they are running those scans? Can we see the report of those scans? And how are the vulnerabilities identified from this exercise? How will they be remediated? So that program must be in place. We must test the effectiveness of that program. Are they following it through? How can we do it again? We can look at the database, look at the last patch that was installed, and try to do a walk back on the process of installing that patch. So how was the vulnerability detected? How was it reviewed? How was it tested? What approval do they have to? So you need to test this program to be sure that it's been working the way it should work. And another thing is the visibility. You can't protect what you don't know. You can't protect what you don't have access to. For you to be sure all your systems are secured, you must have visibility into your entire system space, which means you must know where your systems are. You must have what the systems are being used for, who have access to them, and all this information, it helps you in, again, the risk assessment comes in. What is the risk level associated with that DB? Where do you concentrate your efforts on? How well do you address the risk? Because vulnerability is also a function of the risk associated to what is being stored on the database. If I'm having a critical database, definitely I give more preference to it than database that is just used for probably saving something that is not too relevant to my business. So again, that is also important. Please, you can go to the next page. And this speaks to the vulnerability concerns or issues that we can have around path management. I've spoken to the first one, which is around asset inventory. You won't be surprised. Most big organizations in this world that we think that they are the top notch, they can't even account for the databases or assets they have within the organization. You see assets.
Sorry,
Okay.
Ganiyu. We're almost running out of time, so I'll need you to speed up a bit so that we can have more time for practicals. I'm sorry.
Okay.
I'm sorry.
I'm almost done. Yeah. So it's just for us to identify. Yes. Thank you very much for that, Colin. You have your asset to inventory, like I said, program on how you identify, how you patch, how you test. And again, one of the major issues we have is the reluctancy. It will tell you, IT will tell you, I don't need to patch. I'm not exposed to the internet. OEM has not approved. All these things are excuse. So naturally, we should test and ensure we are patching as appropriate. Then again, we have legacy databases that are not being supported by the OEM again, and we are still using them. In that processes, the vulnerabilities are not, the patches for those vulnerabilities are not applicable again because the OEM is not supporting them and it becomes more vulnerable. Unlicensed softwares, obsolete and scanning tools, and that gives us a false sense of security. You have a scanning tool that is obsolete and it's scanning your server and it's telling you we don't have an issue. It's a false sense of security. So the last point is around data and database objects, and that is the difference. That's the main difference between a storage area and a database. Database consists of storage areas and database objects. Objects are other things within the database that could actually impact on your information, on your record. So we quickly talked about 4 things that as auditors we should be very wary of. The first is around the tables. We all know table is a basic component of database where the information are being stored. How are information stored on database? What form of encryption do we have? PIIs are not meant to be exposed. Things like password, pins, card numbers, and code. Depending on the nature of our organization, we should identify those sensitive information and ensure they are actually encrypted on those tables. Again, another thing is around the data dictionary. DB should be documented. What application or what function or what processes is speaking to each table so that we have a full scope of view of what is being stored and how it is being stored. Then the last is around rows and column level restriction. This is another layer of restriction to our records, and it defines who can access what, even at table layer. So I have sensitive information or information that are pertaining to regulatory. I might be interested in giving this access to only compliance team, so that if every other person, even with a select access, runs a select query on the DB, they won't see those things. So again, it's a function of how our organization is structured and what we have on the table. So the next things are the functions, stored procedures, and trigger. What are these? I'll just use a word to qualify them. They are subprograms that can impact the databases. So how do I mean subprograms? If we are all aware of programming on our phone, I went to my calendar and I call up a calendar. It gives me the date and time. There is a function calling that calendar function, right? So it's just is more of a program within the DB that can actually impact the DB. For functions, we have things like you have a column, and I'm saying column B equals column A times column C. It gives me an automated value. For a procedure is just like a subroutine or a subprogram that's, for example, doing end of day run. All the DB or the database administrator need to do is to initiate the database and end of the activity. That activity calls some procedures or functions or triggers that run some activities within the DB. So we are saying all these procedures and functions, they must be documented. We should know who have access to them. and we should know what they are being used for. They are very key. And we also have things like trigger. Trigger are used to enforce database integrity. Things like dry posting. We all know, for example, in the banking industry, for a debit to happen, there must be a corresponding credit. So a credit without debit should not even fly. It is a trigger that ensures such integrity within the system. So we must be able to account for all those triggers, procedures on the database, know what they are used for, know who owns them, and see how they are being used, especially those people calling them. Is it something in your purview? There are several attacks that have exploited triggers and procedures, things like logic bomb, things like salami attack. These are well-known security glitches that could exploit unaccounted procedures or malicious procedures and functions and triggers. As an auditor, we should be very wary of them. The last item on the list is database link. Database link is more like a shortcut of having remote access. So I have two databases, database A and database B, and I'm only profiled on database A. With a malicious database link on database A to database B, I will be able to access what is on database B, despite the fact that I don't have an access on database B. It's a very complex analogy, but it exists, and these are very key. They should be accounted for. And one of the risks that we could even see with this is the, can we go to the next page, please? So all these are database objects, and these are things that could actually go wrong. So one of the things that could go wrong with all this is the first thing I mentioned, that is the exposure of sensitive information, PII, pins, password, and co. We even need to ascertain as an auditor the type of encryption mechanism that is being used. I'm not expecting us to use AES 64. These are encryption keys that are no longer in vogue because they are readily, you can easily crack them. So we need to see what is being used and how the keys and how the ciphers are being kept. Another thing around the documentation, ownership, purpose, all these functions, procedures, triggers, they must be documented. And we must evaluate and give assurance that they are being used in line with what they are being designed for. Like I said, the database link, one of the risks associated with it is a parallel movement. You end up gaining an unauthorized access to a database you're not meant to have access to. And depending on the privilege that is being assigned that database link, you eventually inherit that privilege. And most of these times, what these causes is unauthorized access. And like I explained, trigger. Once triggers are disabled, integrity of the database has been disabled, then things can actually go wrong. And we have often database objects. Like I said, I have a process that has been decommissioned. The database link was not removed. The process associated with it was not removed. All those things can be maliciously used. And again, distribution denial of access, when probably I have a malicious trigger that keeps popping up and consuming my resources on the system. Eventually, valid transactions would not be able to pass through, and it creates a denial of service. Can we go to the next one, which is the backup? I think this is just as simple as it speaks. Tony already mentioned it. Backup is the act of ensuring our business continuity, and this will be reviewed in line with the recovery point objective, right? The recovery point objective is the least tolerable volume of data we can lose, which means we should have a policy that speaks to disaster recovery and business continuity strategy. What's our RPO? What's our schedule for backup? How often are we backing up? We should review the backup trail. Are we having failed backups? And aside from all this, we should test, because one of the major issues is untested database. You assumed my database is fine, and by the time you are restoring, you realize that it has been corrupt, or probably the backup was not complete. So these are things that can go on with database. And you can see the encryption. One of the standards is encrypting your database. If you have a DB that is not encrypted, all a malicious user needs to do is to dump that DB and mount it on another environment. And lo and behold, your environment has been ported to another unknown environment. And your access is, your data is everywhere on the internet. So I think based on the short time, these are just little areas. Database is extensive, like Tony said, it's more like an 8-hour session. I'm just trying to see what we can crash within this time frame. But if we can cover this space we mentioned, we've reasonably cover securities around database. Thank you very much, and hope I'm able to communicate. Thank you so much.
Thank you, Ganil. Press for time. Okay, Shay, can you share you want to share your slides, your screen, or?
Yes, I'm ready to share.
Okay.
So,
Shay, your time has been, we've eaten up into your time.